Bismillahirrahmanirrahim. Students, welcome to virtual session of week 12 of Introduction to Databases. If you can hear me properly, please raise your hand. Can you hear me? Okay, thank you. Thank you, Amal. Thank you, Aisha. Okay, so I'll continue with my lecture which I was giving in my face-to-face class, and after the lecture you can ask me questions about it. So in our class we were talking about intermediate SQL, and I told you about join expressions and views, and some of the topics were left which I will be studying today. I told you about join operation, that it takes two relations and it results, as a result, returns another relation. It is mostly the results of join operations are mentioned in from clause in SQL. Then I told you that through an example, that when we want to perform a join operation on two relations, let's see this course relation and prerequisite relation. So when we join them, the join can be of different forms which can be done, like outer join, right outer join, left outer join, or inner join. So the outer join is the extension of the join operation that avoids loss of information. You compute the join and then add tuples from one relation that does not match tuples in that relation to the result of the join, and you use null values. So for example, if you are performing course natural left outer join with this, then since it's left outer join, so all the primary keys of course will be included, and the missing information in relation 2 will be replaced with the value null. So the no information from relation 1 will remain missing. So all of them will be included. In right outer join, you look at the second relation and you include all the information from the second one, and the information which is missing from the first relation are replaced with none. There are some join conditions and some join types. The types define how tuples are treated which do not match to any tuples in other relations. So the join types are inner join, left outer join, right outer join, or foot outer joins. Now the join conditions defines which tuples are matched and what attributes are present in the result of the join. So how you will be performing matching and what type of attributes you will be representing in the result. So the join conditions can be natural join, like you are performing a natural, according to the type the join is performed, or you can perform join based on some conditions, some predicate, or by using certain attributes. This is an example of natural full outer join. So the type is natural outer, the type is full outer join and the condition is natural. So these are some more examples of join relation which we studied in our class. Then I told you about views, that in some cases it is not desirable for all users to see the entire logical model. So if you are interested in partial information and you want to hide certain data from the view of certain users, then you can create a view. Any relation that is not of conceptual model but is made visible to a user as a virtual relation is called a view. So you can define a view using create view statement. So you use a create view and you specify the name of the view, and after you specify your query. As you can see here, the name of the view is faculty, and the query is select ID, name, department name from instructor. So you wanted to hide their salary. You wanted to make a view of instructor without their salary. So you made a view and you named it as faculty. You can define your views within another views, like you have defined first view representing physics fall 2009 courses. Then you want to refine it more and you want to have another view from this view, then you can mention you can have another view like create view physics fall 2009 Watson, and you are selecting some of the attributes from it and from the view mentioned with physics fall 2009. So the first view Some of the attributes from first view are used in creation of second view, that is Physics Fall 2009 Watson. You can expand use of a view in a query or another view. As you can see here, that create view Physics Fall 2009 Watson as, so you are mentioning it like this, and in the from clause as well you can expand it, so you can show the expanded form as well. Now I would recommend that you do a lot of practice about this, and you must study the contents mentioned in book, as I can see there that the slides are not containing too much details, but the book contains a lot of details. So you can fully understand all the contents mentioned in slide and all the topics mentioned in slide if you read them carefully from the book. So in book all the details are mentioned, and you can define views using other views as well. And I told you that the view can depend directly, or it can depend on some other, or it can be recursive. Then I told you that you can update a view as well. You can add a new tuple to faculty view, which we defined earlier. So if you have already defined a view, you can add more tuples in it by inserting. So by inserting, if you use insert into faculty, and you can add values in it. So the view was already defined, it was there. But if you want to add more attributes to it, more tuples to it, not attributes, more tuples to it, so you can add in it. So the virtual relation will be, so you can modify virtual relation in this way as well. But some updates cannot be translated immediately. For example, you created a view instructor info and you displayed the name as ID, name, building from instructor and department. So use two tables and combine their information in instructor info view. And you wanted to, and you made the selection based on instructor or department name is equal to department, not department name. So if you want to insert into instructor info values this, then which department, if multiple departments in Taylor, and if no department is in Taylor. So how then you can mention these values. So because whenever you are adding certain values, you need to keep in mind the domain of each of the attribute. So the values you are going to add should be in the domain of those attributes. Most SQL implementations allow updates only on simple views. The from clause has only one database relation mostly, but if it becomes complex if you add more than one relations in the from clause when you are creating or updating the views. And sometimes some are not complicated at all. Like for example, you selected all attributes from instructor table where department name is equal to certain history, you identified all history instructors. So you can add history instructors over here, but it's not possible to add the attributes which is not related to it in it. Then comes the concept of materialized view. Some databases allow you to the virtual relations which you created through view to be stored, but they also make sure that the actual relations remain the same, and the view is kept up to date. So when you materializing a view means when you create a physical table containing all the tuples in the result of a query defining the view. So if you have created a virtual relation and you want to materialize it, it means you should create a physical table for it. If relations used in the query are updated, the materialized view results will become updated, out of date. So you need to maintain the view as well. Like if some information gets outdated, then you need to update this information as well. So just wait for a second. Okay, I'm back. So whenever you are materializing a view, you need to know that the update operation updates the original table and original information from original table and materialized view both. So now let's talk about transactions. Transaction is basically a unit of work, and unit of work. So every unit of work you are going to provide. For example, you wanted to get input, you wanted to write to update a database, you wanted to perform certain operation. So every unit of work you are performing by writing some queries is called a transaction. Now there can be atomic transactions, and the other can be non-atomic, you can say. Atomic transactions are the one that either they should be fully executed or it should be rolled back as if never occurred. For example, if you are in the middle of transaction and and you cannot continue further, then you roll back. You come back to the starting point. You don't leave in the middle. Or you complete the transaction fully without any interruption. So those transactions which either should be completed in full or should not be completed at all are called atomic transactions. Now if you read it from book, the transaction is basically a sequence of query or statements which specifies that how certain things need to be performed. So whenever you are performing the transaction, it should be ended by commit work or rollback work. So commit work means that you are saying that a transaction is complete and you can start new transaction. And if you roll back, it means the current transaction is not complete and you need to undo everything. So it means all the previous statements you performed in that transactions, you are going to undo them. But default on most databases, each SQL statement commits automatically. Whenever you press the enter key after writing the statement, it is committed. So the commit and enter key is considered as a commit in most of the databases. And however, you can turn off auto commit for a session using certain APIs. Integrity constraints guard against accidental damage to the database by ensuring that authorized changes to the database do not result in the loss of data consistency. So you mentioned integrity constraints as well sometimes. For example, checking accountant must have a balance greater than $10,000. A salary of a bank employee must be at least $4 an hour. A customer must have a non-null phone number. So these are the integrity constraints which you add to make sure that the data is consistent. On a single relation, the integrity constraints can be not null, primary key, unique, or check based on some conditions. So you are already familiar with not null. Like if you want to make some attributes not null, it means they should have certain values. And if you are using the unique word, it means it states that the values should be It states that attributes form a candidate key and candidate's key are permitted to be null. Sometimes you use the check clause ensure that a certain it takes on certain values based on some conditions. For example, if you use the check clause is in semester, like check semester in, so it means the semester will be having any one of these values, but it cannot be null. And it cannot have any value other than these. Referential integrity ensures that a value that appears in one relation for a given set of attributes also appear for a certain attribute in another relation. Like as you are familiar with a foreign key, like if you are using a foreign key in one table, then it should be a primary key in some other table. So whenever you are writing database queries as well, you need to keep these things in mind. Then you can make cascading actions in referential integrity as well. Like you can refer to the, for example, you create table course. You mention course ID, title, department, which is referring to the department. So it is foreign key over here, and you can define department name as a variable, and you can mention it that it is a foreign key and it is reference from department, and these are the operations which are allowed on it. So you can say that these actions are possible on this. I'm going to skip this. You can write complex check clauses as well by writing queries within sub-queries as well. So for example, you want to specify that every section has at least one instructor teaching the section. So you can perform a check that either the instruction is every section is allocated one instructor or not. But in many databases, writing such sub-query is not supported, so we are not going to go into more details of this because none of the databases support this. Like create assertion command does not work. Now let's talk about the built-in data types in SQL. The data types built in SQL are date, time, timestamp, and interval. So these are related about date and time. So the format for date is this. As you can see here, the time for day can be entered in hours, minutes, and seconds. And timestamp, and you mentioned the time key. You mentioned the time. Use the time clause to mention it. And you can mention the interval as well. Like you can say 1 day, or you can use you can use certain formulas as well to mention this. So once you have created your table, you can create index as well. Like indices are data structures used to speed up access to records with specified values for index attributes. Like you are saying that select static from student where ID equals this can be executed by using the index to find the required record without looking at all the records of the student. So you don't need to look at everything. You can just look at the index and you can bring up the data. You can have your own user-defined data types as well. So you can have your own data types, define your own data types like create type. By using the create type construct in SQL, you say that create type dollars as numeric, and you can mention the attributes required for it. When this way, a new data type will be created. You can create domains constructs as well. So a new domain can be added, but it is not supported by all the databases. You can specify the types of domains. You can add constraints like not null, etc. Large objects like photos, videos, CAD files, etc. are stored as large objects in databases. It's called blob and clog. Blob is binary large object. Object is a large collection of uninterpreted binary data. And clog is a corrected large object. It is a large collection of corrected data. When a query returns a large object, a pointer is returned rather than the large object itself. So it is kept in memory and its pointer is returned, and from that you can access it. Now on databases there are certain types of authorizations you need to have to perform certain operations. The form of authorizations on part of database can be read, insert, update and delete. So if you have read authorization, you can read but you cannot modify data. If you have authorization of insert, then you can insert data but not modify existing data. If you have update authorization, then you can modify but cannot delete. If you have delete, then you can delete as well. So when you authorize different people for different operations in database, it is based on the combination of all these. To modify database schema, there are few more authorizations possible, like index allows creation and deletion of indices. To modify database schema, resource allow creation of relations, alterations allow addition or deletion of attributes in a relation, and draw allows deletions of complete relations. And to specify authorization specification, to write authorization specification in SQL, you use the grant statement. It has syntax like you give grant, then you mention privilege list, and on which relation you want to grant permission, and then you mention user list, like to which user you want to grant permissions. The privileges in SQL, like I told you that in grant you are going to write privilege list. So what are the privileges? You can give them privileges to select, to insert, to update, to delete, or you can give all privileges. The revoke statement is used to revoke authorizations. This has the same syntax, similar syntax like revoke and privilege list on the relation name on which it is provided, and from this user list you can specify multiple users as well. You can define your roles as well, like create role instructor. So grant instructor. So what you can do is that you can define different roles and then you can assign different permissions to those roles. So whenever a new relation is created, you can authorize roles to use that relation, or you can give different roles permissions to use that relation. Like for every resource, you are going to now define that which role is allowed to have, like to perform which operations on the resources. Like chain of roles, for example, create role dean, grant instructor to dean. It means dean has some authority to modify, for example, to insert, update, read the contents from instructors, and we grant dean to someone else. So someone else has authority to perform certain operations on deans. And same is the case with views. You can give authorizations on views as well. So just like you did for relations, you can do it for views as well. And in the same way, you can grant, you can revoke them, you can grant reference, etc. So these are all the contents we had for you had to study in this week. If you have any question, you can ask me now. Okay, since I am turning my microphone off, but I am available. If you have any question, just type in the text panel, and I'll answer. I'm waiting for your questions. Thank you very much.